Okay, today we're going to be talking about section 6-7, which is talking about functions and their inverses. So when do you have an inverse? You have an inverse when you have a function. A function exists if it passes the vertical line test. So one, it has to pass the vertical line test, and meaning it only can choose one x, can only choose one y. Okay? Then, not only that, it must be a one-to-one function passing the horizontal line test, meaning now not only does one x only choose one y, but on one y must choose exactly the same x. Okay? The domain and the range of the functions are inverses, so they simply swap. So my x becomes my y becomes my x. Okay? The graphs of f of x and f inverses are reflections over the line y equals x. And then the composition of them have to equal x every time, forwards and backwards, f of f inverse and f inverse of f. Same exact thing. So with that being said, what does the parent function look like? The parent function of a line goes on forever in both directions, so the domain is x is an element of the reals. The range, it goes from bottom to top, so that's going to be y is an element of the reals. Okay? This right here is going to be x squared. And that looks like a u, okay? The domain of that, since there's arrows, that means it goes from left to right for the entire axis, so therefore x can be anything it wants to be, so it's an element of the reals. However, the range is read from bottom to top. Then whenever you read it from bottom to top, you first run into it at the value 0. So this is y is an element of the reals, but then y has to be greater than or equal to 0. Okay? Absolute value. Absolute value is going to be our nice V graph. Looks like a valley or a V, okay? We still have arrows on the end of it, so that means we are still going to have our domain be x is an element of the reals, and it goes on forever. And then our range, we read it from bottom to top. Again, that is going to only start whenever y is greater than or equal to 0, okay? Then our last function I want you to remember is going to be our spaghetti function. Your spaghetti function looks like this. The domain of that is x is an element of the reals because I have arrows on both directions. And this is just like the line graph, so therefore it's y is an element of the real as well. Okay, so that's our domain and our range. And that's what the parent functions look like, and I kind of need your brain to remember those parent functions. Now, with that being said, how do you determine if an equation is a function? Well, it has to pass the vertical line test. What this means is, from back in the day when we talked about this in section 2.1, we said, who in here wants ice cream and candy? Everybody raised their hands for they want ice cream. Everybody else raised their hand for candy. And then the minute that you raised your hand for both ice cream and candy, you are no longer a function. So basically the question that you ask yourself is, does your x repeat? 1 chose 5, 2 chose 7, 3 chose 5, 4 chose 6, and 5 chose 7. Therefore, the x's did not repeat, so yes, this is a function. Over here, 1 chose 5, 2 chose 6, 3 is choosing 5 and 7, so therefore, no, this is not a function, meaning there is not an inverse, okay? Over here, 1 chose 6, 2 chose 5. Look, 3 and 4 did not choose, so no, this is not a function. So this is the review from whenever we did this in chapter 2, section 1. And then how do you determine if it's a one-to-one function? Well, if it's a one-to-one function, what this means is every x value in the function has chosen exactly one y value, and that same y value may not be chosen by any other x value. This is what a true marriage is supposed to be. I am married to my husband, he is married to me, there's nobody else in our relationship, it is a one-to-one function, okay? Now, if I were talking about ice cream, I'm going to choose chocolate fudge brownie. Mrs. Numbers would choose chocolate peanut butter. Miss Moore would choose grape sherbet. And Miss Crimebell would choose Oreo. What this means is nobody else can choose that. It has to only be those flavors. Okay? Oreo chooses Crimebell. Chocolate fudge brownie chooses me. Nobody else can have it. The whole entire gallon is mine of chocolate fudge brownie. Nobody else can have it. That's what a one-to-one function is. So 2 goes to 3, there's only one arrow going to 2, and there's only one arrow going to 3. That is okay. Since all of these only have one arrow, yes, this is a one-to-one function. However, 7 is choosing negative 23 over here, and 11 is choosing negative 23, which means this is not one-to-one. That is not a one-to-one function. Okay? So you cannot have a one-to-one function there. Next, the domain and the ranges swap. So if I have my domain is all your x's and your range is all your y's. If this is my given function, then my inverse means that all of my x's now become the y's over there, and all of my y's now become my x's over here. And you can see that that is exactly what has happened, so therefore these are inverses because their xy tables have completely swapped. Okay? Next, number 4. Number 4 said it had to be reflected over the line y equals x. This dotted line right here that you see, do you see this dotted line? It intersects at 0, 0 and has a slope of 1. That's what that means. That is what it means to be y equals x. Now, the reflection means that I can take this ordered pair right here. This ordered pair is going to be 1, negative 2. So if I have 1, negative 2, then the inverse of that is going to be negative 2, positive 1. So if I'm at negative 2, positive 1, there's that ordered pair. Over here, I have an ordered pair, and that ordered pair is going to be 1, 2, 1. So its inverse is going to be 1, 2. So I'm at 1, I'm at 2. Then this ordered pair is going to be at 1, 2, 3, and then 2, 4. So its inverse is going to be at 4, 3. So if I graph the point 4, 3, that puts me right here. And basically what I can do now is I can just draw a line, and you can see that they're all equal distance from the line y equals x. What do I mean by that? Well, I'm going to go ahead and show you. Do you see they're equal distance there? They're equal distance there. They're equal distance there. They'd be equal distance there. Okay? That's what it means to be reflected over the line y equals x. That's how I can tell graphically. Okay? I swapped my x and y's, and I get a new graph. Okay? And the last thing is the composition. So if I go ahead and do the composition, if I do f of f inverse of x, that means I'm taking my f function and I'm plugging in x plus 5 over 2 for it. My f function is 2x minus 5, and I'm going to plug in that for it. So that's going to be 2 times x plus 5 over 2 minus 5. The 2's cancel out, so you have x plus 5 minus 5. 5's cancel out to give you x. Meaning, it doesn't matter what I do, if I have found the inverse of a function, and I go ahead and I plug in a number 3 for it, of the composition of them, f of f inverse of 5, it gives me 5. F of f inverse of 6, it gives me 6. F of f inverse of negative 2032, it gives me negative 2032. Let's go ahead and check it the opposite direction. F inverse of f of x. So that's f inverse of 2x minus 5. So that means I'm taking x plus 5 over 2, and I'm plugging in the 2x minus 5. So I have 2x minus 5 plus 5 over 2. The 5's cancel out. The 2's cancel out, and I'm left with x. So I've proved that both directions, they're inverses of one another, so therefore that's the definition of inverse. Keep going. How do I find an inverse? Well, you are simply going to replace the f of x notation with, you're going to replace the f of x notation with y, okay? Then you're going to swap x and y, switch them. Then you're going to solve for y, and you're going to replace y with f of x, inverse. So let's do that. Now, I give you y equals 2x plus 8. The first question you have to ask is, does this have an inverse? Well, this is y equals mx plus b. We know that y equals mx plus b is a line. So I have to find out if it passes the vertical line test, which yes. And then I have to find out if it passes the horizontal line test, which yes. So once it's passed the vertical and the horizontal line test, I know that the inverse exists. So I'm going to go ahead and I'm going to find that. So y equals 2x plus 8. I'm going to simply swap out x and y. And now I'm going to solve for y. So I'm going to subtract the 8 and divide by 2. So that means that f inverse of x is equal to x minus 8 over 2, which is the same thing as 1/2 x minus 4. How did I get that? Divide those, okay? So that is how you find the inverse. So here we go with this. I did not give you this as a parent function, but the parent function of the square root, we've already looked at this before, is the one-armed bandit. Remember I said it's the parabola flipped on its side? So basically what you have to do here does this pass the vertical line test? Yes. Does it pass the horizontal? Yes. So it does have an inverse. So how do I go about this? Replace y, f of x with y. Swap out x and y. Now solve for y. How do I get rid of the square root? You square both sides. X squared is equal to y minus 2. X squared plus 2 is equal to y. So f inverse of x is equal to x squared plus 2. Now, I want to make myself very clear about this. On your homework is going to ask, is the inverse a function? Well, this is x squared. X squared looks like a parabola. So yes, it is a function, but is it a one-to-one function? One-to-one function says it passes the horizontal line test. No, it is not a one-to-one function. However, I can take y equals x squared plus 2. Actually, let's make this x minus 3 squared plus 2, and I can find the inverse of that, okay? How do I find the inverse of something that looks like a parabola? It does not pass the vertical line test. It does not pass the horizontal line test, I mean, okay? It passes the vertical, but it does not pass the horizontal. So in order to ensure that you have an inverse, you drop one of the arms. So you literally are going to drop the arms at the lovely axis of symmetry. The axis of symmetry came from this part right here. So x minus 3 is equal to 0, so greater than or equal to 0, so x is going to be greater than or equal to positive 3. We are only going to choose this part of the function. We are not going to choose the left side of the function because you can't take, it won't pass the horizontal line test then. So we're going to restrict the domain, and we're going to only view it when x is greater than or equal to 3. Why greater than or equal to 3? Because that is our horizontal shift, okay? So I'm going to swap x and y. Then I'm going to solve for y. So I'm going to subtract 2. Then I'm going to go ahead and take the square root of both sides. So I'm going to have plus or minus the square root of x minus 2 is equal to y minus 3. Had to have the plus or minus there, but then I'm going to go ahead and add the 3. So I'm going to have 3 plus or minus the square root of x minus 2 is equal to y. Now, the plus or minus now is going to be tossed out because I only want it for whenever it's greater than or equal to 3. So therefore, I'm going to have 3 plus the square root of x minus 2 is equal to f inverse of x. And I'm only using the positive portion because what happens is you turn it on the side, and when you turn it on the side, I don't want the bottom part of it, I only want the top part of it, okay? Actually, I lied. I don't want the top part, I want the bottom part, okay? So this is going to be your answer, not the plus or minus. Tonight's homework is 6-7, worksheet 1, inverse of functions.